Okay, how does carbon, nitrogen, oxygen, hydrogen join together to form organic compounds? If you still remember, carbon consists of 6 electrons, and in the orbital box notation, which you learned last semester, okay, it will be 1s2, 2s2, 2p2. Organic compounds consist of non-metal atoms such as hydrogen, carbon. Okay, restart. Organic compounds consist mainly of non-metal atoms such as carbon and hydrogen. These atoms are put together through covalent bonds to give the organic molecules its shape. In the food flavoring industry, the shape and size of the flavor compound affects the intensity of the flavor. Okay, for example, in chocolate, the shape determines how quickly the chocolate melts in the mouth, and this determines the order and speed that different food molecules are released onto the tongue and into the nose. Because dairy milk has changed shape, it will melt differently in the mouth, potentially changing the release of molecules from its ingredients and its flavor. An example of a flavor compound found in food is called theobromine. It consists of carbon, oxygen, nitrogen, and hydrogen. These compounds form covalent bonds, single bond, double, and triple bond to give the shape that brings the desired chocolate flavor. However, the shape and size of theobromine are highly toxic to dogs. This is because dogs metabolize theobromine at a much slower rate than humans and are often fatal to dogs even at lower dosages, which is why we should never feed our dogs with chocolate. Okay, if you remember from the chemistry module, CLF 103, Physical and Inorganic Chemistry, you learn the two methods to write the electronic configuration. We have the SPDF notation, which is written in sequence according to the atomic shell number and orbital energy level, as well as the electron in box notation, in which the orbitals are represented by a box and the electrons are represented by an arrow. Okay, if you recall what you learned last semester on the periodic table, the electron shells exist as SPDF orbitals. S subshell is the first shell that is nearest to the nucleus. Okay, it's called the 1s orbital. It is spherical in shape. There's also another orbital that you will learn, which is the 2s orbital. It's larger and higher in energy than the 1s orbital. For the P subshell, it is dumbbell shaped. The orbitals are directional as the orbital can be arranged in 3 coordinates: the x-axis, the y-axis, and the z-axis. So we'll call it the px, py, pz orbitals. P orbitals have higher energy than s orbitals, and all 3 orbitals are at the same energy level. There are 3 methods to assign electrons to different orbitals. If you recall, you learn about the Aufbau principle, in which the electrons are filled in the orbitals in a way to minimize the energy of the atom according to the order: 1s, 2s, 2p, 3s, 3p, 4s, 3d, and 4p, and so on. We also have learned about the Pauli exclusion principle, in which 2 electrons in the same orbital must spin at opposite direction, and is denoted by the up and down arrows, and also the Hund's rule. If 2 or more orbitals of equal energy are available, the electrons occupy each with their spins parallel until all the orbitals are half filled. So how does the carbon, nitrogen, oxygen, and hydrogen join together to form organic compounds? Okay, last semester you learned about the SPDF notation. For chemical bondings in organic compounds, the orbital involved are only the valence orbitals. Thus, for hydrogen, it will be 1s. For carbon, nitrogen, and oxygen, it will be 2s and 2p orbitals. Let us see the electrons. Okay, let us look at carbon. Carbon consists of the notation is 1s2, 2s2, and 2p2. Okay, so remember the different rules that we need to apply. Okay, we need to fill in the lower energy levels. Then after that, if for the same energy level, they are filled in singly before they are paired. Okay, for nitrogen, you have 1s2, 2s2, and 2p3. For oxygen, you have 1s2, 2s2, and then 2p4. And for hydrogen, you only have 1s, which is only one electron, so it will be alone in a 1s box. The shape of the orbitals in reality, for 1s orbital, it is spherical in shape. For 2s orbitals, it is also spherical in shape, but larger in size. For the 2px orbitals, you will see that it's a dumbbell shape, but lying flat on the x-axis. And for the 2py orbital, it will be in the direction of the y-axis, and for the 2pz orbitals, it will be in the direction of the pz orbitals. How does carbon, hydrogen, oxygen, and hydrogen join together to form organic molecules? If we see the different atoms, we can find from the periodic table which group do they come from. From carbon, it comes from group 4, and thus it will have 4 valence electrons. For nitrogen, it comes from group 5, so it will have 5 valence electrons. For oxygen, it has comes from group 6, so it will have 6 valence electrons. For hydrogen, it is from group 1, or it has only 1 electron, so it will have only 1 valence electrons. So what will be the number of electrons to achieve the octet or the 2 electron configuration? So we need to have 8 minus 4. So carbon needs 4 more electrons to achieve the octet of stable configuration. For nitrogen, it needs 3. For oxygen, it needs 2. And for hydrogen, it just needs another electron to achieve the octet or 2 electrons configuration. So the number of bonds carbon can form will be 4 bonds, nitrogen 3 bonds, oxygen 2 bonds, and 1 bonds for hydrogen. Okay, and thus what are the bonding possibilities? If you look at carbon, because it can form 4 bonds, so it can form 4 single bonds, or it can form 1 double bond. A double bond is considered as 2 bonds, 1 double bond and 2 single bonds. Or it can form a triple bond followed by a single bond. It can also form 2 double bonds, making the 4 bonds. Then next you have nitrogen. Nitrogen can form 3 single bonds, or it can form 1 double, 1 single bond, or it can form 1 triple bond. For oxygen, it is able to form 2 bonds, so it's able to form 2 single bonds or 1 double bond. And for hydrogen, it can only form single bonds. Okay, so this is a revision of what we have gone through. For carbon, okay, you find from the periodic table is from group 4, so it will have 4 valence electrons. The number of electrons required to achieve the stable octet configuration will be 4, and number of bonds it must have will be 4 bonds. Yes. And later on, we'll learn about the shape of carbon when it has 4 single bonds. If you see here, the carbon has 4 bonds to the hydrogen.